Hello, my name is Ken Young, and I'm the chairman of the Electrical and Computer Engineering Department. I would like to congratulate all of you on your acceptance to UCLA. Now, this time of pandemic has been difficult for all of us. I truly wish that I could be speaking to you in person instead of over this virtual Zoom. This disease has also not made college admissions any easier. So you have proven yourself to be among the very best of the best, and you should be extremely proud of your accomplishments. Now, you are fortunate that with the vaccine, the campus and all its wonderful facilities, our department with new teaching methods and new technologies are now available in the fall just in time for your arrival. To give you a quick sense of the ECE major, you only need to look at the world around you, the phone that you're spending time talking and texting with, the screen that you're watching YouTube, Netflix, or even this presentation on, the watch that you're wearing that actually helps you track your exercise and gamify it, the goggles that you'd wear to be able to wander in a 3D virtual world, the machines and algorithms that plot your detour when you hit some traffic. ECE pervades your surroundings in your lives. So, to be a bit more specific, what is ECE? It's the what, the elements that processes and stores information, that communicates between our devices and frankly between us, that senses the signals in our world, our environment, our bodies, and helps us diagnose and control it. So our classes are teaching you devices, transistors and antennas, circuits, amplifiers and logic gates, building blocks that we then assemble into computing systems and implement processing architectures, tools that we use to analyze, to design, and to simulate, algorithms that are being used for signals of various forms, audio, visual, and control, protocols for communication, and of course, user interface. So with this skill set, you can then take another look around you and you quickly see places that ECE has not yet played a role, and therefore the opportunities and the potential that are in there. So again, congratulations. I welcome you to join later our sessions to learn more, and I look forward to you joining us. Thank you.
My name is Ebira Wan, and I'm the Vice Chair for Undergraduate Affairs. And I would like to welcome you all to UCLA. You are among a very select group of people. This year, the admission rate, I don't know if you know already from other information, but something like 8% to the School of Engineering. The average GPA unweighted was 3.9. The average weighted was 4.6. So congratulations and welcome to one of the best departments and universities worldwide, actually, not just here. So we're very proud of our department. And before I go on, I would like to see if you know what EE is about, or ECE in our case. Electrical engineering in general is about, it's not about, fixing TVs. When I was younger and I would tell people I'm studying EE, they say, oh, do you know how to fix my TV? That's not what it is. Electrical engineering is about applying information or ideas or theories from math, physics, and computer science to develop devices and software. And it's a very diverse field, and it has many people doing everything from applied math to building hardware devices. So it's very broad. And a degree in EE will open many career doors for you. It's interesting that graduates from our electrical engineering department can either go into software or hardware, but can also go to law and medicine, can go on to business, because it really provides you with solid foundations to be in any career and succeed in it. Why UCLA in particular? We have a very active student body. You'll hear later from our student clubs. Really incredible. They've won awards, national awards, about because they're so active and involve students. And of course, the university is world class with its students and faculty. We have incredible resources. So if you're interested in dance, there is something. If you're interested in philosophy, and just biology, economics, all these departments are world class. And so it really provides you not just the engineering experience, but also the social experience and uh, information to utilize, for example, medical schools across the street from us, and many of our students do internships or get jobs at the medical school. So it's very, very unique in terms of the resources and the excellence of it in the diversity. So you'll not just grow as an engineer, but as a good citizen and as a person, because it opens up your eyes to so many possibilities. Um, what is different again about our department in particular, there is a program called the Fast Track program. Typically, students are admitted at time of admission, very selective. This is for students with really incredible academic records, and they take honors classes when they come here, and they're guaranteed internships. Even if you are not selected at admissions time, you could still apply later on once you prove that you actually do well. So some students did very well when they came here and they got admitted. So again, the nice thing about this is it has guaranteed internships. It has but you have to maintain a certain GPA to take honors classes. But this program is just incredible, and there's nothing like it that we know in the country. We also have a lot of support, whether from faculty or your counselors. Our counselor for EE is Miss Marianne Geber, who is here on Zoom, and she's very helpful in terms of helping you plan your courses and how you take them over 5 years. And then you have peer advising students and clubs, and older students can help the younger students. So there's a lot of support provided by our department and by the school. You can even do be a teaching assistant. If you do really well in a particular class, you can help out. So we have a particular class called EE3, which our freshmen take. And if they do well, again, they can be a teaching assistant in the following years. There's also a possibility for undergraduate research, and some of the research that our undergraduates have done is just incredible and got published in journals and conferences. We have honor societies like Tau Beta Pi HKN, again, very active. HKN actually is ranked as one of the top chapters in the country, and they do workshops. They help you, let's say when the career time, the career week comes, they help you with polishing up your CV. They offer tutoring, a really incredible service and support. And then you have IEEE and WAT. They will talk about that, but they also have incredible design experiences. I mean, we've had students, with an okay GPA, but got into Google and top places because of the design experience that they found, not only in class, but in these student organizations. And so there is lots of hands-on possibilities. And faculty are world class. This is just some listing about how many of our faculty got awards in terms of teaching. I'm specifically talking about teaching here, but of course research is just as much. This is a picture of a professor with, these are the books that our faculty wrote. And so they're very involved. They're all textbook quality and they in their field. So we not only are faculty involved with teaching and care a lot about the students, but also they're really excellent researchers. You advise our students to plan their courses early. We have on the website a plan on what are the courses you take. This is one example, and what are the different paths. So usually the first 2 years, everybody does the same thing in terms of physics and math and some other courses, but the last 2 years, we call them upper division courses, it gets to be more specialized. So if you're interested in software, you go to, for example, signals and systems. If you're interested in circuits, there's embedded circuits track, there's computer engineering track. So depending on which track you want, you might want to take your electives that feed into this track, that make you learn more about it. And we help the students choose these kinds, so they really they have the breadth, but they also have the depth in certain areas depending on their interest. And as I said, we have students doing undergraduate research and doing incredibly well. For example, we've had about 70 undergraduates each year do it, mainly juniors and seniors, although in the past year or two, more actually sophomore and freshmen have been involved in research. And some of it is summer research, some of it is during the year. There's also a class which is called 99, which gives you credit for the research that you've done. And there are summer opportunities where the research, our EU site, so this is called Research for Undergraduates, and other NSF-sponsored projects. But also, I would like to say that our department is unique because from freshman year, you get introduced to engineering. Usually in other schools, the first year or two is just the basic physics and math, all that. But within the past 5 years, we've changed our curriculum so that our freshmen from year one will know what is electrical engineering. So we have 3 opportunities. We have something called ECE1, which is basically just a seminar course where we bring in alums, successful alums from Disney, from Qualcomm, from Apple, and every week somebody talks about their experience. So our freshmen know eventually where is this leading them to? It's leading them to design or medicine or law or program management. Then we have a class called E96, which is research, hands-on research experience. And again, this is at the freshman level. And I don't know of any other university which has that possibility, this many courses. And then we have ECE3, which is we give you a little kit and you build your project around it, and a very dynamic class. And so you get really hands-on experience. So again, as freshmen, you'll have these 3 introductory courses just to give you a flavor for what electrical engineering is, what engineering is in general. And again, I don't know of any other universities which does that. As I said, the research, there are different possibilities. You can either do sponsored research, actually get paid for it. It's called REU. And there's also something university-wide called Undergraduate Research Fellows Program and Undergraduate Research Scholars Program. Again, this is something you can apply to within UCLA, and your research doesn't have to be strictly in engineering. You can be doing something with psychology or with medicine or with linguistics. And some of these are paid positions. There's also Howard Hughes, which tend to be a bit more medical, pre-med type research program, something called CARE, LEADS. It was a whole bunch of possibilities to work in research, and some of it are paid. You just have to apply and show interest and take the right courses, and you can do this. This is just some examples of some of the research that our undergraduates got involved in. For example, they built a device to physical therapy, to help with physical therapy, activity monitor for newborns. There is a project they got involved with 3D printing for microfluid channels. There's some on signal processing and analyzing speech signals. Or imaging using DNA molecules on a mobile phone. So let's say you're a doctor in a remote area, you don't have access to the lab, you only have your phone. This tool will allow you to do analysis on your phone and share it. Okay, so I have a message here. Anyway, so again, this is just a listing of the different societies. Sorry, and IEEE, HK, WAT, etc., and they'll be presenting today. And as I said, there's just a list of their awards and what experiences they had. And we do cutting edge research. Many of our faculty are either fellows or members of the National Academy, and the department is top ranked among the universities. Now, where do our undergraduates go? This is an old survey, but the trend is very similar. About 60% go on to industry and 40% go on to grad school. 20% grad school and 20% other. So either, I mean by grad school in engineering or computer science, and other, I mean, could be business, could be law, could be medicine. So, and these are the type of companies that hire our alumni, all the top ones and small ones as well. So there's no shortage of jobs for an electrical engineer and computer engineer. So we wish you a very happy, successful time at UCLA. We hope that we will see you all in the fall. You are a select group of students, and you'll get a really good picture today about what our department is about. So now my time is up, and I'm going to hand it over to Professor Gupta.
Thanks, Abir. I hope everybody can hear me.
Yes.
And let me share my, I have just one slide. I'll go through it and just introduce all of you to the computer engineering degree program that we have. And it's a relatively new program. And currently I serve as the vice chair of this program. This is a unique program in the sense that it's being jointly run by the ECE and the computer science departments. And at least in my belief, it is essentially a best of what EE offers and what CS offers in terms of their curriculum and opportunities. It's a very healthy mix of both hardware concepts and software concepts. Eh, just to give you an idea, in context of hardware, the focus is far more on digital systems, which is what computing substrates end up using. And there's not much of a focus on kind of the physics leaning parts of EE. I mean, there's a little bit at kind of early years just to get you an introduction. And so the other parts of EE, which like devices, photonics, antennas, analog, hot circuits, etc., there the focus is far more reduced in case of CE. Again, similarly, software focus is much closer to hardware and a little bit less on the more formal aspects of computer science. And then there's a bunch of courses and curriculum which are kind of shared between EECS and CE. Things like algorithms, machine learning, processor architecture, embedded systems, et cetera, et cetera. The curriculum is very forward-looking and therefore very evolving. Computer engineers get a very, very broad training, and that's why if you ask anybody where can computer engineers work, it's almost everywhere. Uh, it's very tough to think of a job opportunity which is kind of would hire an electrical engineer but would not hire a computer engineer, or would hire a computer science grad but would not hire a computer engineer. They're very, very few. So they work as architects, digital circuit designers, design tool developers in hardware companies like Intel, Qualcomm, NVIDIA, Cadence, Boeing, etc., and as well as software engineers or embedded system designers in software or system companies like Google, Amazon, Facebook, Microsoft. I mean, the list goes on. And moreover, the distinction between the so-called hardware and software companies is becoming sort of somewhat gray. And that's what makes computer engineering even more attractive, because this is sort of one breed of engineers which are equally well-versed and comfortable, whether be it kind of building hardware or programming on top of built hardware. Obviously, still there are places where computer engineers are not great fits. So for example, on the E side, if you're really, really looking to do hardcore EE, things like RF circuit design or being a coding theorist, etc., then absolutely EE is a better bet. Similarly, on the computer science side, if you're really looking at very deep CS aspects like building compilers, for example, then yeah, probably computer science is a better bet than computer engineering. Computer engineering is anticipated to be probably the single biggest growth area for ECE. There'll be more faculty, more course choices coming in. Just in the last 3 years or so, we have hired quite a few computer engineering faculty and who are offering quite a few new undergraduate computer engineering elective courses. There are new courses in security and privacy, in human-computer interaction, robotics, machine learning for IoT, and this is all that has been added in just the last 2 years. So that's just giving you an idea of how this curriculum is going to keep on evolving, and it'll be kind of always, it's a very, very vibrant area. So a stagnant curriculum just doesn't work. And we realize that, and that's why by design, the CE curriculum will evolve and keep on changing. I think I'm out of my time, so I think I'll hand it over to Rob. And if they have any questions, the best time would be in the breakout session. I'll be there and other faculty would be there. And if you have any questions about computer engineering, I'll be happy to answer them at that time. Thank you.
Thank you. Now, Professor Candler.
All right. Thanks, Puneet and Abir. So Good morning, everybody. I want to take just a few minutes today to talk about a title here, Mission Possible, Why UCLA Professors Are Great Researchers and Great Teachers. So, you're probably aware that there's a whole bunch of fantastic research that goes on. So you might, hopefully not, but you might have some thought about what teaching at a research university might look like, and you might imagine it's something like this. So this is for a show Futurama from Matt Groening, the creator of Simpsons. So here's a scene. Hey, professor, what are you teaching this quarter? Oh, same thing I teach every quarter, the mathematics of quantum neutrino fields. I made up the title so no student would dare take it. Great, I'll be there. And then the kicker that always gets me is, please, Fry, I don't know how to teach. I'm a professor. So, I'm really hopeful that you didn't have that thought, but if you did, I'm here to disabuse you of the notion, because here's what it actually looks like. Where the research that we do really informs the teaching. And so it's what keeps it kind of both of them fun, is the way they interact. I have just one picture here from Ankur Mehta, Professor Mehta. He does a lot with robotics. And so this is one of his classes where they're doing, this one was a self-playing guitar, but every year they have different projects that teams work on, and it's really fun. And he has an open house where all the faculty and students are invited to come see the projects at the end of the quarter. So, this is kind of how it really works. And also, how I like to put it for UCLA is you get the best of both worlds. So we're a large research focused institution. So there are all sorts of research opportunities. And I think Professor Alwan mentioned the variety of clubs and activities. I always tell students, whatever you can imagine, they have a club for it here. And so you come and you find your passion. These pictures are just one of a former undergrad researcher of mine showing how electronics work to a group of high school students. He was a beatboxer, and so he was beatboxing and showing kind of how the frequency components broke out. On the right, this is me and a couple undergrad researchers. We went to Washington, D.C. for this Posters on the Hill event, where they presented their research they did in my lab to senators, Congress people, all sorts of science officers. It was really kind of interesting 2-day experience. And so that's the kind of the big research opportunities you get, but you still get personal interaction. So there's undergrad advising. So every student is assigned a faculty advisor and meet with them ideally 3 times a year. At least once a year, you'll see your advisor. And we have smaller upper division classes, and we still get personal interaction even in large classes. And so, I think we'll give that a go right now. So we're a big group and we're virtual, but let's see what we can do with that. So there was the topic here is active learning, and there was a study. There have been multiple studies actually where you come in and you take a class. This study was done inside a classroom, but let's say we'll do it virtually here. So here's the beginning of class, and time runs. Let's say I'm giving a lecture. I'm going to teach a number of different topics to the end of class. And so now we've hit the end of class, and I hope you're paying attention because we're going to have a quiz. All right. And so in this study, they actually did that. Someone like me went and gave a lecture. Right at the end, the students were given a quiz. And the quiz covered material from the beginning, the middle, and the end of class. Okay. And so what the studies did was they looked at the percent of students who answered questions correctly from, let's say, the material that was showing up at the beginning, some materials from the middle, and some was from the end. And then you stepped out right after the end of the class, hand you this quiz and see how people did. Now, what I want you to do is I want you to think about, just take 30 seconds and think about what you think the shape of this curve looked like. So there was a right answer, but there's a button. If you hadn't seen the study, there are quite a number of logical kind of feasible explanations. And so what I'd like you to do is put your guess in the chat. So you can just say what you think the curve looked like, and I'll wait a second and we'll start looking at some of them, and then we'll talk about what really happened. Okay, all right, yeah. So I see one exponential decay, so I'm paying attention. Oh man, now I'm zoning out, and even though something else came at the end, then I've forgotten it. All right, I see a inverted bell curve. All right, nice. So I'm paying attention. I zone out in the middle, I'm sleeping, and okay, parabola similar. And then right at the end, hey, I'm focusing. Oh no, I got to learn some stuff. And so that short-term memory keeps like 5 minutes in, slowly decreasing with a small bump at the end. So, oh man, I'm forgetting, but at least I can remember a little bit there. Oh, all right. So I see random. So that could be, yeah, hey, we don't know when we're going to remember. Yeah, exponential because you spaced out and don't remember anything at the beginning. Oh, exponential rise. I see. So yeah, so that's another logical one. Hey, I can remember the stuff I just heard, but from the beginning, I've lost it. All right, so kind of a bulb at the end of the class. This is great. Okay, so we've covered a lot of different shapes. So I will let me tell you what it actually looked like now. So here's what happened. So ostensibly you get in, students are still settling in the first few minutes, are not really zoned in, and then they lock in pretty well. And oh man, now we have this precipitous drop off. And this one is always still a surprise to me. The lowest percentage was right at the end of class. So, okay, here's a material. Answer is, X, and then you step out. What's the answer? I don't know. I forgot. And so that's, why do I show you this? Is this to depress you? No, it's not to depress you, because you realize that with the thing that matters, from my point of view as an educator, is the area under this curve, right? Because this is the overall knowledge that I've transmitted. And so the reason that I show you this is not to disappoint you, and certainly not to chastise anybody, but it's to say there are other ways that you can improve this. And so one big way is active learning. And really, in a nutshell, active learning is engaging your mind, so you're not just passively listening and absorbing, but getting you involved. And they've shown that really kind of triggers, and what it'll do is it'll pop up the learning. And so, we do an active learning exercise just like we did now, and it jumps up, and you say, all right, well then, are we good forever? No, we're all human. It's going to start to decay again. But then you can insert these exercises. They don't have to take but maybe 1 or 2 minutes. And so what you can do is, now you see before the curve went here, all of this extra area is extra learning. And so, that's what we're here to do. And so this is something that I use quite a bit in my class. And Rick Wessel, our Associate Dean for Education, actually started a teaching workshop where they cover a number of different topics. And I go and learn a lot about it. And then once a year, I go and I teach about active learning, so that we can kind of spread this out and give other faculty opportunities to implement these sorts of things. All right, so thank you for your participation there, and thank you for your attention. So if you have questions, you could post them in the Q&A. I'll try to answer them, but as Professor Gupta mentioned, probably the best way is we'll be in the breakout rooms at about 11:20, I believe. So you can come in and ask questions or put them in the Q&A, whatever, and we'll do our best to answer them. All right, thank you.
Thank you. So next are the student clubs, and IEEE, HK, and WAD, and you guys can have a few extra minutes because we took some of your time. So please go ahead.
Yeah, sure. Let me just pull up the screen share really quick.
We're very proud of our student clubs. They're extremely active, and they get students involved, and they win awards. So it's really wonderful to have them.
All right, there we go. Oh, I gotta share my sound too, so I'm gonna quickly reshare. All right, can everyone see the slides?
Yes.
Great. All right, so hi everybody. My name is Brian. I'm currently a third-year CSE major here at UCLA and the president of the IEEE student branch. And first of all, thank you so much to the EC department for giving me the opportunity to speak about the club today. And also a huge congratulations to all of you for getting into UCLA engineering. Now, I think that UCLA is a really great environment for a growing engineer. And in my opinion, one of the biggest parts of that are the different student organizations around campus. There are so many different diverse organizations run by some really talented people, and you can get a lot out of them. And I'm hoping that IEEE is one of these organizations for you next year. So what exactly does IEEE do? Well, we are the largest ECE-focused community of engineers on campus, hosting over 100 events every year for over 250 members. And this ranges from everything from project lectures to technical workshops, to socials, industry events, and even our very own hackathon. So quickly, I'd like to play a promo video.
Welcome to IEEE, home to many UCLA electrical engineers working on some cool projects, and proud host of California's largest collegiate hardware hackathon. Congrats on making it here, and we can't wait to show you what we have to offer.
All right, so the first thing I'd like to touch upon are our projects. So the projects really are the essence of IEEE, and every year we have over 250 participants in some project, and no matter what experience level you come into UCLA with, we have a project for you. So if you're somebody who has never touched a circuit before, like I was when I came into UCLA, our open project space program is really great. It teaches you all the skills you need from the ground up, and it's really beginner friendly. If you have a little bit more skill or skills coming in, so say maybe you did robotics in high school, or you were working on some circuit projects, then maybe Micromouse or Aircopter would be a better fit for you. And if you're really advanced, so this could be maybe a couple years down the line, you could participate in our FPGA project dev or RF communications project rep. And in addition to all these, we also have drop-in technical workshops that you're free to join, and it's totally non-committal. And really, joining a project here at IEEE is a really great way of getting some technical skills that are relevant in either securing some industry internships or even doing some research down the line. And because we have such a wide array of projects, it's really something that you can join during your first year and continue to participate in all throughout your senior year and continue to learn something new every year. So most of our first years end up joining the ops program. So I'd like to quickly showcase some of the things that you'll build. So you'll build things including a distance sensor, a music player, and an autonomous maze following car, as well as a bunch of different other projects. And here are some pictures highlighting some of our other projects. So on the top left is a micromouse. So you'll see that it's a PCB card that you basically design yourself and program and implement some maze solving algorithms. And then you get to race them against students from other colleges and compete for some cool prizes. At the top right is an aircopter. So there's a 3D printed quadcopter chassis there. And you get to also design the PCB and program it yourself. Sounds really cool. The bottom left, we have one of our new projects, DAV. So this involves taking some audio input, filtering it through an FPGA, and then displaying it on the monitor there. And in the bottom right is our beloved IEEE lab. So you can see there, it's really busy with students working on projects. It's also a great place to work on some homework or even just hang out in between classes. So fingers crossed that we'll be able to give you guys the full IEEE lab experience for next year. Now, in addition to projects, we also offer a lot of other different types of events. So as I mentioned before, we have Idea Hacks, which is our collegiate hardware hackathon that we host every year. That one's super cool, and you get to build cool prizes and then compete, or build cool projects and compete for prizes. We also have our general board program, which is our upperclassmen and officer mentorship program. It's a great way of meeting some more experienced students, as well as getting to know some friends within your own year. And the top right, that's one of our, that's my general boards event from a couple years ago. We made dumplings for dumpling night, pre-COVID, of course, and hopefully next year we'll be able to have some more of those type of events. In addition, we also have industry panels, alumni mentorship, boba and Korean barbecue socials, SPAV, which is an event where we get to tour company campus and talk to some representatives, as well as beach day. And there's really just so much more that I can't cover within the limitations of this one presentation. But if any of this seems interesting to you or you'd like to learn more, we'd love to have you. The best way to connect with IEEE is through our virtual Discord, our email newsletter, and then our Facebook group. So I will post the link to our link tree below. So you can actually find all of these different links here. And we have Discord lab hours every Monday through Friday from 12 to 5. So feel free to pop in, have a chat with us. Sometimes we're playing some games. So it's not too early to get involved. We'd love to hear if you guys have any questions. And if you have anything else you'd like to learn more about IEEE, feel free to ask during our breakout room later. But yeah, thank you to all of you guys. And once again, a huge congratulations for getting into UCLA engineering.
Okay, let's get a round of applause for IEEE. They're an amazing organization, and yeah, I think you guys should check them out if you guys decide to come to UCLA. Yeah, and again, congrats on getting into UCLA. It's an amazing experience for engineering. So, hello, my name is Cody Fan, your biggest fan, and I'm the current president of Eta Kappa Nu. So who are we? We are an honor subgroup within IEEE, and we're centered around encouraging and recognizing academic and professional accomplishment. We host about 30 events every year, catered mostly to electrical and computer engineering undergrads. And we invite the top fourth of junior standing electrical and computer engineering students alongside the top third of senior standing students to induct into our organization. And overall, we induct about like 60 students every academic calendar, given they fulfill our induction requirements. So there are three things that we hope to support you on your engineering journey even if you don't induct into HKN. And so the first of which is academics. So we hope to help you out in your classes through tutoring. Right now we host tutoring from 12 to 7 p.m. on a Discord server from weeks 3 to 9. I know when I was an underclassman, I would drop into HKN pretty frequently and just get help on stuff I got stuck on. And we also host technical workshops where we teach programming languages and tools like Python and Verilog that you would use in your classes, and also in industry and other research projects through many projects involving image processing or machine learning. We also host review sessions where we review and solidify concepts at the end of quarter so that you ace your final exams. And we also host professor talks where you get to learn more about what the faculty at UCLA does research on. So the second thing we hope to develop on your engineering journey is career development. So we do that through a number of ways, including professor lunches, where you just get to network with the various faculty at UCLA. We also host a large career fair in the fall, where you just get to talk to a lot of like top companies like Northrop Grumman and et cetera, about working at their company and talking to their reps. We also host a research fair where we try to match students with labs at UCLA, and then we also host corporate information sessions and professional panels where you'll get to talk to companies about working at their company, or you'll get to talk to alumni about postgrad opportunities, including graduate school or industry. And last but not least, we like to have fun. At UCLA, there's a big work hard, play hard culture. And so, we love to play video games, go on hikes, do Korean barbecue. During like Zoom University, some favorite social events have been chess tournaments and Among Us socials. So thank you for listening. Currently, our website is down, just like the economy, but our websites are working hard on it. But what isn't down is our Discord server, Facebook, email, and Instagram. So feel free to just join our Discord server, email us, like us on Facebook, and follow our Instagram. And thank you again. And congrats on getting into UCLA.
Great. So Wesleyan from IEEE WAD. This is one of our newest groups. It's started a few years ago and from some students, and it's become really successful. We're very proud of them too.
Yeah. Hi, everyone. Welcome. Congrats on getting into UCLA. We're super excited to have you. I'm Weslyn Clark, and I'm the president of IEEE WAT, which stands for IEEE Women Advancing Technology Through Teamwork. And I'm a fourth-year electrical engineering major. And why can't I go forward? Okay. So our mission is to recruit and retain more women and other minorities in electrical and computer engineering. So we accomplish this through these 6 different types of events and programs. So the first is outreach. We encourage younger students to study STEM through outreach events at K-12 schools and organizations. So this year we've had 6 virtual outreach events so far, which includes workshops and panels we've done and hosted with the Archer School for Girls, Girls in STEM, and at some of our officers' high schools. And actually up here is Allison. She is one of the founders of this club, and she's actually on this call today. So we also hold professional events for students to get in contact with recruiters and learn important professional skills. These types of events include networking nights, info sessions, and workshops. So we've collaborated with many companies, Intel, AT&T, Qualcomm, Northrop Grumman, and Google, just to name a few. We also hold advocacy and wellness events to remind students to take care of themselves through workshops dealing with mental health, de-stressing, productivity, and promoting healthy habits. And so we collaborate with ACMW and SWE, which are 2 other large organizations on campus dedicated to empowering women in engineering. And we work with them on Empower Week, which is aimed to provide a full week of events geared towards empowering women in engineering. So our mentorship program is probably my personal favorite part of the club. We match new admits with older undergraduate students as mentors, and then that pair is matched with an alumna mentor. So our program is called Hogwarts. It's Harry Potter themed, as you can tell. And each pair is placed into one of 4 houses. So it's Hufflepuff, Slytherin, Ravenclaw, and Gryffindor. And so these houses compete for points to win prizes at the end of each quarter. And this year we have 20 mentor-mentee pairs and 12 alumni mentors. So this is how I personally first got involved with WAT, and it's a great way for students to get involved and become part of a community. We also hold technical workshops that allow students unfamiliar with electrical engineering to familiarize themselves with some basics and other related skills. So some of the examples of our workshops are LED paper crafts. We normally host that with SWE. Learning the Linux command line, which was something new. Also wearables, which you can see up in this picture back when we were allowed to be in person. And we also started a new long-term project this year. It's 2 quarters long. It's currently ongoing, and it's a Raspberry Pi project. And basically, we are building a Face ID unlocker using some machine learning along with Python and a Raspberry Pi. So here are all of our socials. I will link our website in the chat, and through our website, you can find all of our social links. It's just much easier to find for you. But that's all for me. So thank you so much for your time, and I look forward to hearing any questions from you guys later in the Q&A session.
Does anybody, if you guys have questions, please place them in the chat and we can address them. This is just for students. The student panel will be a little bit shortened to 10 minutes instead of 15 because we're over time. One question is, do professors teach or TA specially? No, professors teach oral courses. There are no students, not even postdocs teach our classes. So only professors teach students, even in the first year. Any other questions? While you're thinking about the question, I just want to introduce quickly Miss Marianne Geber, who is our counselor in Dean Wessel's office, and she's incredibly helpful. Marianne, you want to say a few words?
Yes, hi everyone. Welcome to EE. Congratulations to everyone who is here and got into UCLA Engineering. It's a great accomplishment. I work in the Office of Academic and Student Affairs, which is the main counseling office for the School of Engineering. And we are here basically to support you in any way we can as far as course scheduling. If you have questions about your requirements, submitting petitions, scholarships, we do everything from admissions all the way through to commencement. So we're here, obviously right now we have a virtual presence and we're doing everything via Zoom and everything, but hopefully in the fall, at least some of us will be back on campus. So look forward to seeing you then.
Thank you, Marianne. Going back to the student panel, anybody has questions for them, for the students? Okay, what about, okay, maybe I'll ask a quick question. What is your experience with summer internships? Brian or Cody or Wesleyan? You're muted, sorry. Oh yeah.
Okay, sorry, I wasn't sure if these questions were for us specifically. I've had 2 internships in the past. The first personally was during the summer between my sophomore and junior year. And it was at an electric vehicle startup in the Bay Area. I personally got it by going to the LA Auto Show and just talking to a company that I was interested in interning for. And I met my manager doing that. And my second internship was with Northrop Grumman between my junior and senior year. That was made virtual because of COVID, but I got that by going to the Women in Engineering conference in 2020 and talking to recruiters there.
Thank you.
Yeah, I can talk a little bit about my experience too. So I've had one internship last summer. I'm a little bit more on the software side. So I was a software intern for Amazon last summer. And this summer I will be a software intern for Lyft. I also tried really hard my freshman year to get an internship, but no dice there. But I will say that I think something that helped a lot with securing an internship for the following year was spending that summer productively. I took some summer classes at a local community college and also started working on a lot of different personal projects, trying to basically build my resume and get some stuff on the board. And I thought that that was a huge help. And I think another thing that definitely cannot be undervalued are the power of having some upperclassmen friends that you can draw upon for some referrals. So I think that joining an organization like IEEE, like WAT, like HCAN, building those connections, just making friends and having them able to give you referrals to these companies can definitely be a huge help in securing internships.
Yeah,
Thank you.
building on that point, I think, at least from my experience, I've done mostly research in my summers, but I think research is a great way that can lead to internship opportunities. So yeah.
Just a quick question about if anybody's interested in the situation, whether it's going to be in person or not in the fall. We hope to be in person, but there's also a website you can check, and I'm going to forward it to you, and you can check it over the summer because they update it. But right now the plan is to do that. There was a question about majoring. Is it possible to double major or minor? I guess, Marianne, you want to say something?
Yeah, I've been answering that in the chat. Yes, it is available. It is possible to do a minor or a double major. Samueli Engineering has 2 minors, which are bioinformatics and environmental engineering. And I think there's going to be a third, hopefully in data science very soon. But if those 2 minors aren't interesting to you, you can also minor in something outside of engineering like math or physics or anything else. Some people do it in economics. So yeah, it is possible to either double major or minor in something. You can't double major in 2 majors within the School of Engineering, but you can have one in engineering and one outside of engineering.
I think there was a question. Let's see, we talked about the internship. I think we'll just have 2 more minutes for the questions. If we don't get to them, we can also ask the breakout session. So that's a popular one, the major and the minor. About career fairs, there was a question about career fairs, and the career fairs are great, and they start early, actually, in the fall. Companies start recruiting kids for some internships in the fall, and but we have several career fairs. We even have one which is only special to our department. So UCLA, we do as a university and as a school and as a department, we work with you to help in securing internships. Professor Wessel also answered the question about major. How easy to switch majors to other fields? I guess, well, yeah, anything is possible. I mean, so as long as you express interest and your grades, and some departments have requirements like you have to take X, Y, and Z. So to be able to switch either into or E or out of E, but you have to check out that. But it's a fairly flexible program, but you have to check out the requirements for each department. 1 more minute, and then we'll move on to our alumni panel. What's the latest for us to switch major? Again, as I said, it depends, every major has different requirements. CS has its requirements, ES has requirements. So as long as you satisfy that, it should be very possible, especially in the first 2 years. After 2 years, it's very hard because then, you can really get delayed in your graduation. But the first 2 years, especially the first year, it shouldn't be difficult to switch. I'm going to have to end it right here because we're a little bit behind schedule, and I would like our wonderful alums to present. And any other questions will be answered in the breakout sessions.
All right, so I think it's time for me to take over. Let's see, do you see my video?
No. think you have to do share screen.
All right. So, I guess what you're seeing now is my thruster screen. Is that right?
Yes, we see your
All right.
screen.
All right.
By the way,
Yes.
oh, I wanted to, sorry, Bill, is Bill still around, Bill Gooden? Okay, never mind.
Yes, I'm here.
Oh, yeah, I was wondering if you could introduce Dan to, because I think he'll
Oh,
be too humble
certainly.
to talk about himself.
Oh, so glad to introduce Dr. Dan Goebel, who's one of our outstanding alumni, who's a member of the National Academy of Engineering, has been a GPL for many years, maybe many years, in a very senior role. He also is an adjunct faculty member teaching aerospace engineering classes, and has been a valued member of our alumni community and School of Engineering partner through the collaborations between UCLA and JPL, and many students have benefited from his wisdom and teaching over many years. So I'll let him tell you how many years that he's been associated with JPL and UCLA.
Well, thank you, Bill. So first of all, I'm pinch hitting today for the chairman of the alumni panel, which is Dr. Abami. He's ill, unfortunately. So I don't really have a presentation, but I do have some notes, and I'll just talk to those. As Bill said, this is an alumni panel of people who went to UCLA and feel really strongly that it was a fantastic experience, not only in their life, but in their career. And I'm going to talk a little bit about why they're in the alumni panel and what we do. The alumni panel is composed of people that graduated 1 or 2 years ago, all the way to people like me who graduated about 40 years ago. So it's been quite a while. And that diverse group of people gives us insights into near-term career activities. How do you find a job, and helping students find jobs? To, in my case, since I teach at UCLA and I come from industry, I give a lot of guidance to what the curricula should look like. So the alumni panel is really put in place as a kind of a positive feedback mechanism to help the department be as relevant as to their students and to helping their students go further in their careers as possible. I want to mention that all of us think that UCLA was a great experience. I already said that. And in my particular case, I think that I actually found all of my jobs because of the people that I had met or been graduate students with at UCLA. And so even the opportunities of the people who hired me, the jobs in the Southern California area, all came from the fantastic networking and communications and interactions with other UCLA students and other professionals in the field. And that's all made possible by the fantastic professors and capabilities at UCLA. All right. So what is the Alumni Committee really trying to do? We're really trying to make it a great experience for students and graduates going forward. And I noted in my notes that we really basically have 3 jobs. And so I'm going to explain what those are and why they're important to you, why you should care. And the first one is that we arrange internships. All of us work in industry in Southern California area, California in general, but Southern California specifically. And we often organize internships. We organize the number of positions that are available. We help to communicate with the department when they are available and help find students to fill those internships. And so that's a real role for us as an interface to the companies out in the Southern California area. And also, once you graduate, we help you to get the job interviews and to get placement in different positions in the Southern California area. And you have to understand that UCLA is really perfectly situated. Southern California is still the largest aerospace conglomerate in the world. We have more aerospace work and aerospace companies than any other major employers of electrical engineering people. We have the entertainment industry, largest in the world, also major employers of double E's. And we also have a lot of entrepreneurs and innovative tech companies. And large companies start here, like SpaceX, and small companies start here that then grow and become large companies. And a lot of our students become entrepreneurs. And even I worked at a small company for a while when I first graduated. It's a valuable experience, and it's because that's all available here in Southern California, close to UCLA. And we help, the alumni panel helps interfacing with those. Another role that the alumni panel has is to give some feedback and guidance to the ECE department. And what we really tell them is what do we, as experienced people in industry, in the job market, what are we looking for? And if you take some of the examples you saw earlier, they talked about the clubs, and there's the Maker program, and the many opportunities now for undergraduates to get hands-on experience and to participate. That all came from the alumni panel. We went to the dean and to the departments and to the different people in engineering and said, we need students to have more hands-on experience, and this is how it's evolved over the last 10 or 15 years. And that's the role of the alumni department, is to say, the alumni panel is to be sure that the department knows what industry is looking for and what skills you as students coming out would be very valuable for us. And the last thing is to organize networking. And I can't say that enough. And the real reason is that it isn't good enough just to come out with spectacular grades and a degree. You've got to actually know some people and be connected and be able to find jobs, be able to find internships. And the alumni panel is a major organization for that, organizing that network. We help you find people in industry, we pair them up. There's a very large mentorship program where we actually help you find people in industry to talk to. And so this networking really is how you progress as you go forward in your career, not only just to find internships as an undergraduate, which is incredibly valuable. You all need to do that. And there are more internships available at UCLA than any other university that I know of because of the Southern California area, but also because that's ultimately where you will find your jobs. So we already talked a little bit, you've been hearing things about the opportunities at UCLA, and very few universities are located close to these other schools. We have a business school, a medical school, law schools, especially the medical area. There are very large collaborations going on, and that's all made possible by how great UCLA engineering is, and UCLA electrical engineering specifically. It has spindles into all those areas. And you really should consider that there's such diverse applications and possibilities that it's really great for students to get involved in research in different areas. Also, if you look out in the Southern California area, or even in the California area, the graduates from UCLA are actually major players in industry and in the field. Our people have been leaders of Northrop Grumman and Lockheed Martin. The person with his name on the building, Henry Samueli, who, by the way, I went to school with, he's a co-founder of the largest chip maker in the world, Broadcom. We've also had our faculty have founded part of the internet. We've worked on commercializing sensors. I work in space propulsion, electric propulsion, and so I'm on a mission right now that's going to be using some of my propulsion technology that you see on my screen to go to an asteroid. It's field after field after field is being led by UCLA graduates who've been able to succeed both in classrooms and then in the job market. So the bottom line is that UCLA, in my opinion, is the best place in the world to get an education and enter a really huge, thriving industry and market. And our alumni can attest to that. And what I'm going to do now is let the alumni introduce themselves briefly, and then we'll open up and see if there's any questions. So for the alumni panel, the people that are online, if you please unmute yourself, please give your name, go ahead and give your UCLA degree and when you got it, and a very brief description of your job. I think the first one on the list is Allison. I saw you earlier.
Hi. Just a second. I'm going to spotlight everyone so that it's just easier to see everyone. Is that okay? I think I'm co-host. Let me add Juwan.
Well, that is a good idea. I should have organized that early on, but like I said, I'm teaching things.
Alex. Okay, I think that's it. Is that it? Seven of us. One, 2, 3, 4, 5, 6, 7. Cool. Hi, everyone. My name is Allison. I graduated from UCLA a couple years ago with my BS in electrical engineering with a focus in computer science, a technical breadth in computer science. And now I am a software engineer at the Chan Zuckerberg Initiative, which is Mark Zuckerberg and his wife Priscilla Chan's philanthropy in Redwood City. I didn't really know what I wanted to do after college, and I really appreciate that electrical engineering is such a broad field. And so I really had the door open to a lot of other fields. And UCLA allowed me to explore all these fields, which is also very nice. And I just chose to do software because I felt most comfortable after that doing in college. But I know a lot of people in all different fields, so I encourage you to consider doing this major, even if you're unsure, especially, after high school, you don't know what you want to do, but I think EE is a great place to start. And hopefully can answer more questions about that later. I can popcorn it to my dad, David.
All right. So I'm David Dawami. Let's see, I'm also a UCLA EE grad, graduated in 1986, well before many of the other folks on this panel. Let's see, and I currently work at Northrop Grumman, about 15 miles away from campus, and actually started there in the area of electromagnetics and antennas. And currently I am a director of all of our MILSATCOM programs. So these are military satellite communications programs that support our Department of Defense in the United States. And I guess one of the things that I like to do is continue to engage with the UCLA community. I'm regularly helping to mentor and recruit UCLA grads for Northrop Grumman as well. So key thing certainly to help me keep connected, but also to bring on lots of great engineers for our company as well. So, and then I will hand it off.
Ron, can you take over?
Sure. Hi, everyone. My name is Jiwan. I graduated with a bachelor's in computer engineering in 2019, and currently I'm a hardware engineer at Facebook. Yes, Facebook has hardware positions too. And I work on supporting the data center infrastructure for Facebook. So I always tell everyone, I ensure that your cat photos and memes are properly stored and readily available for you to view. So yeah, pretty fun stuff. I was heavily involved in IEEE when I was in UCLA, also Watt and many other great clubs. So I look forward to talking to you guys in the breakout rooms. And I will pass it off to Wenry.
Hi, everyone. I'm Wenry. I graduated in 2014 with electrical engineering from the antenna microwave design pathway. And I'm currently working at Qualcomm as a product and test engineer for power management integrated circuits. So my job is just to make sure your phone doesn't blow up. And so you're welcome. And while I was at UCLA, I was mostly involved in a research lab by Professor Ethan Wang. I wasn't really in any student groups, but I did take advantage of HKN's tutoring sessions and workshops. Those were always helpful. And Erica was the president of HKN back then, so I will pass it on to Erica.
You're muted.
Thank you. My name is Erica Skoglund. I graduated UCLA in 2013 with an EE degree. My career path has been a little bit more winding. I no longer work in the tech field. I run commercial development and product strategy for a early stage healthcare fintech company. I went to Texas Instruments and did sales and account management out of UCLA and recently graduated from business school. So if you guys have any questions about the doors that an EE degree from UCLA can open, I'm happy to talk about that in the alumni breakout session. Like Wenry said, I was also the president of HKN when I was at UCLA and cannot speak highly enough about the student groups and how they really enhance the lives, both in terms of like getting through classes and the community among the students in the EE department. So I would highly, highly recommend the major.
Hi, everyone. My name is Alex. I graduated from UCLA with a degree in electrical engineering with a tech breadth in CS in 2017. And after I graduated, I actually started working at Viasat, a satellite communications company, where I worked on FPGA development in digital design and software development. Just this past year, I actually recently changed jobs to work at Intel as a system validation engineer. And I work on the data center products ranging from server CPUs and workstations. And this is to help empower the world of data because a lot of technology moving forward in the coming decades will be data driven, and Intel's on a mission to make that happen. On this, I also was part of IEEE back in my day for 4 years working on projects, and I served as an officer. And last but not least, I am actually currently doing my part-time online master's with UCLA, doing focusing on data science engineering. So if you have any questions about grad school, I'd be happy to answer as well. With that, I look forward to answering all your questions and getting to know you.
So I think actually on the schedule, we have a few minutes here for questions if anybody has any. You can do it on chat. But in the meantime, I would like to hear from Erica a little bit more about the opportunities that a double E career degree gave you in other types of fields.
Sure. So going through the classes, I knew that I think my personality just lent itself to roles that dealt more with people. So I like specifically looked for those types of roles and found that the double E degree opens the door to this world of like technical sales and marketing and systems and all of these roles that you don't think of as traditional double E degrees, but really like value that degree and require that degree to do the work. And so when I went to Texas Instruments, there was a technical sales and marketing rotation program. And for that experience, I think opened up the door for an MBA and countless opportunities after.
That's great. So first question is how does the class student group balance work? Is the class workload very high? So the recent graduates, Allison, Yvonne?
Yeah, sure. I can share my experience. So coming out of high school, I probably did, I don't know, like 6 different activities in high school, and I was like always busy, and I wanted to continue doing that because I thought high school is, well, it wasn't easy, but it wasn't as hard as I thought, or college was much harder than high school. And I thought I could handle it. And so in freshman year, I joined racing, I joined IEEE, I started WAT, and I also joined club tennis. And I definitely got rid of some later on because school just got really hard. But I do know plenty of people who were able to learn how to balance their time early on. I just needed to learn how to do that, and because classes were much harder than they were in high school. And so you just gotta learn. I think EE especially, in my opinion, is probably one of the hardest majors at UCLA. And yeah, I had to learn how to balance my time a lot better than I did in high school. But yeah, John can share his experience too.
Yeah, I'll add a little more to that. And so I think what's unique about student orgs is that you can control your own workload for student orgs. So you can get as involved as you want. So if you don't have time, right, you can just simply, go in for a couple of meetings, say hi to everyone, be in their labs, make new friends. And if you want to get even more involved, you can join their year-long projects and such. So I think, yeah, student orgs are generally super awesome to join. And depending on your workload, you can change that up or mix it up however you want.
I'll also add one more thing, that classes and grades aren't everything in college, and that a lot of the time, like networking and clubs and like going to certain events, like the end purpose of college is to get a job, right? And so like meeting the right people at the right time can sometimes be a lot more beneficial than like studying another couple hours for a class rather than, meeting someone, like meeting a recruiter and getting an internship after that. And so, yeah.
And I think actually that you need to balance your personal life and your schoolwork. And I know I spent a lot of time playing basketball, and the beach is 3 or 4 miles away. So not only would we go to the beach, of course we would study at the beach, but we were at the beach or the rec center. There's just lots of activities and things to do. And now with all the club arrangements and IEEE, and so there's lots of activities that you can participate in. But it's really the opportunities are there. You need to arrange it. And if you do it, it turns out to be a very positive experience. I wanted to mention is one of the questions, which part of college was the most important to you? In my particular experience as an undergraduate, I worked in a research laboratory. And so I was an undergraduate research tech, and that was just a really valuable experience for me to meet these people, work closely with the professors, and get some experience in research. And it was just a great part of my experience. And I think that's very important. And other people should also here talk about what was their best experience.
I'll touch on that. For me, I think the best experience was the people I met. I can truly say that like all of my best friends that I'm still in touch with are friends that I made through HKN. We do like an annual trip, and I'm quite a few years out of school now. So like it really, really was like a very like fun, powerful environment. And talking to like the work-life balance, like there were so many nights where we'd be like studying in someone's apartment and then wrap up and then go out and like get a drink together or transition to like just hanging out. And so it really was possible to balance it and have a good time.
Another question. Go ahead, please.
Oh, I was going to add that I also worked in a research lab, and that actually helped me rule out PhD as my career path. So I think not everyone would enjoy research, and it's only after you experience for yourself that you would really know like what path is right for you. So I think just go explore different things. Yeah.
Oh, I like to add as well. So I actually struggled a lot when in my first year at UCLA, and to the point where I actually almost switched out. But luckily, I was part of the IEEE student org, where they really showed me a lot of the different projects that are possible with electrical engineering. And that's something I really can see myself doing in the future. But not only that, it's also an entire community of like-minded individuals who are just as passionate about electrical engineering. And it's that community of working together and to help each other grow into doing greater things. Like that's what I found really special about UCLA and in particular electrical engineering. And all those skills actually help a lot in the future, such as getting into jobs, getting to grad school, research opportunities, helps you for the rest of your life.
Yeah, I guess, sorry, Dan. Well, one more comment. So I think not only from my personal experience, but I think what I've seen as a hiring manager for hiring UCLA students is there really is a much stronger sense of community. The student groups at UCLA are so strong, and I noticed a question about what kind of resources are there to help students who need help with classes. Well, all of the various student groups that we talked about or that you heard from all have tutoring sessions and that kind of thing. But the projects that you work on also complement what you learn in school or in the classroom, let's say. So definitely, one of the reasons I like to recruit at UCLA is that the students are very kind of teamwork oriented. They build leadership skills through those student groups and projects. and you know, for my industry, right, aerospace, we have teams of people who have to work well together with each other, and so we're really looking for people who work well together. It is unlike some schools who have a reputation for, you know, being very cutthroat, and the students are all out to you know, undermine each other to get the top grade. That is not UCLA, and really are fortunate to get students who at our company that from UCLA that have that real sense of teamwork and camaraderie and that kind of thing.
And I found that when I was there, and even in the classes that I teach now, a lot of engineering students are kind of quiet. They don't necessarily have the best social skills. And at UCLA, it turns out that there's so many opportunities that they just get drawn into clubs, and they get drawn into activities, and they get pulled by other students into things to do. And that networking is extremely important. It makes for not only a better social life, but also then a career path. And that's really a natural part of UCLA. I think that, like David said, it's very different than some other schools where our job at UCLA is that everybody does well. And that works out an enormously positive situation for most people. Let's see. There was a question earlier on up in the chat about what kind of experience should you have coming into engineering. And I'll just open that up. Does anyone, do you need any experience? I think you just need, you want to learn and you want to do things and you want to go build things. That's what an engineer should do. And UCLA will give you the tools for it. Anybody?
I love what Wenry said earlier about using all of the different opportunities to explore your interests. I think there's so much available that like testing that out and figuring out what you're drawn to can really help you be deliberate about the experience that you craft in the following years or what path you choose to pursue or specialize in. And so definitely try to take advantage of like all the opportunities out there.
It's actually funny, I should tell the story that my niece was admitted to UCLA engineering, and she was also admitted to a small college down in San Diego, and she's actually debating it. And I'm like, there is no debate. You know, UCLA has so many opportunities. You can find things and do things. And you know, there will be things come up that you see that you had no idea, and you'll find you were fascinated in it, and you'll go and spend your entire career in that area. You only find that at the University of UCLA that is so diverse and has so many opportunities, has so many programs that you have great exposure. And that's one of the great things about UCLA. So I hope to convince my niece of that also.
Yeah, I think Allison mentioned earlier that she came in and she wasn't sure what she's gonna do in college. And same thing here, I was undecided, not even engineering, but just undecided when I came to UCLA. And quickly discovered that, oh, I really love physics. I wanted to major in that. And coming from a Chinese family, my mom thought that was impractical because that's not job oriented. So I chose engineering to convince her that, okay, I'm going to do something proper for my life. And yeah, so quickly, like I tried different courses from different departments and narrowed down like what major I wanted to choose. So yeah. It's okay if you had no prior experience or even knowing like what you want to do, and also what you want to do could change over the course of your life. It's not that you major in electrical engineering, then you're set, like Erica proved that you can also explore other fields as well.
All right. So Avir, I think it's almost 11:20 or 11:20, and we're going to go into the breakout rooms now. And this group will still be in its own breakout room. So please join us there, and we can continue with the discussion and answer any questions you might have.
Thank you. Thank you very much. This was really interesting. So now we're going to have the breakout sessions. And as directed in the program, we have the one for alumni and the one for research and the one for students. So choose the one you want. And we'll see you in a couple minutes.